Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with predictive analytics and that too coverage on machine learning. In fact, it is also one of the kind of forecasting technique through which you will do the kind of forecasting as per the management requirement. In fact, in the kind of forecastings, we have a two different structure, linear structure and nonlinear structure, and we can have a different kind of situations. In a particular situation, we may have a single variable through which we will do the predictions for that variables by using different techniques. And in fact, we have discussed so many time series techniques through which we will do the similar kind of predictions with respect to information of a particular variables and the requirement of futures. And again in the other case, we can have a multiple number of variables through which we can do the similar kind of forecastings, that to dependent variable with the many independent variables, and we can have a time series data, that is historical data, and again use the historical data for the future predictions. So, in the machine learnings we have a similar kind of structure, but here we can follow two different setups altogether. Having first of all, you have to see how many variables are there in the systems and how many observations are there in the system corresponding to all these variables. Let us start with a simple structure, that is with respect to a particular variable, and then we have to check how many data points are there. And in the time series setup, technically we may have actually more number of data points, so that the prediction and forecasting can be very perfect as per the particular management requirement. So, having actually more number of observation in a particular setup, so the time series forecasting typically in the machine learning process. So, we divide the entire data set into two parts. So, first part around 70 to 80% we keep it for model development, and then remaining data points we will keep for testings, model testings. Then finally, so the develop models and the kind of testings. So, we can finally come with a particular structure that the model is perfectly ready now for the future forecasting or future prediction. So, that means whatever we have discussed in the previous lecture with respect to time series time series forecasting, and that too we use the total number of data points for the forecasted model, and then we get the forecasted figures, then the particular obtained of particular error terms with respect to actual values and the kind of estimated value. So, obtaining the error component with respect to actual value and estimated value. So, we will give you the kind of model accuracy, then through the indicators like mean square error, mean absolute deviations, mean percentage error, we can finally check the validations, and then we can go for the kind of prediction and forecasting. So, here in this particular lecture, so we will go for similar kind of similar kind of framework, and then we will develop a particular modeling framework through which we will do the forecasting of a particular variable with respect to time series data, that to historical data. So, in the machine learnings we have a couple of techniques, starting with the artificial neural network, random forest, support vector machines, and then we will follow a structure called as simulations and the kind of data mining. But in this particular lectures we try to cover neural network, and then we will follow up with random forest and support vector machines. These are all interesting machine learning techniques through which we do the time series forecastings or similar kind of forecasting as per the business requirement. It is actually similar kind of time series models, but a little bit structural difference is there to do the kind of forecastings. So, here in the artificial neural networks, the whole idea or the basic approach is we have actually input clusters, and these input clusters will be connected to a particular output forecasting. So we can start with one input with one output, or we can start with many inputs with one particular output. Then how these inputs are connected properly with respect to time series data, and then we will go for the output prediction and output forecasting, that too with the training and the testing, so that the model accuracy will be perfect before you start the prediction and the forecasting. So, this is one of the interesting technique, that is ANN, artificial neural network. It is an information processing system, and usually inspired by the biological nervous system, such as human brains information processing mechanisms. It is composed of a large number of highly interconnected processing elements, that is technically called as neurons, and the neurons are technically clustered and classified, and then they can be learned properly to develop a particular structure through which you can do the kind of output forecasting. So, this is actually typical framework through which actually you can go the output forecasting with respect to the kind of input availability, and the usual structure of neural network is like this. So, what I have already mentioned. So, we can have actually input clusters, and our job is to predict the output, and when we have actually input structure and the kind of the prediction of output. So, what will we have here? So, we can start with one particular input with one particular output, or then you will do the structuring to do the kind of forecasting. But in the other sides, we can have a multiple number of inputs through which you will do the similar kind of output forecasting. So, compared to one input with one output, it is not so challenging, but when we have a more number of inputs through which you can actually predict the particular output, it will be very challenging. So, how these inputs can be actually combined, in a what way, in a what kind of structure through which the output will be perfect for the kind of prediction requirement. So, this simple diagram can narrate the particular structure. So, this is the input structure. So, this is the first and availability, and our target variable is output, which is also available, and then this is the mechanism, neural network mechanism through which it can it will help you to process to predict the particular output. An artificial neuron is a device with many inputs and one output. So, this is a simple structure altogether in a kind of artificial neural network framework. The neuron has two modes of operations. So, what I have already mentioned, that is the training mode and the using mode. So, first we use some data to create a kind of training structure, then we use this training data for usable way to predict the output the kind of requirement. So, what will it do technically? So, the structure is like this. So, with this help of input and the particular structure, we will go for the output, and that too in a kind of modes like training mode and using mode. So, let us see how is the particular structure. So, in the kind of training mode, so the inputs are trained properly to predict the output, but in the using mode, so the input pattern can be detected through the training modes, then it will be finally connected with the output forecasting. So, it is a kind of simple framework through which actually you can do the typical neural network forecasting, and in the particular neural network structure. So, the typical understanding is it is a pattern recognition, and this is one of the important application of neural network. So, how to actually recognize the particular structure, that is through training, and then once you recognize properly the kind of arrangement, the kind of combinations. So, that will be properly identified and connected, then the output need to be forecasted as per the requirement. So, now in the kind of neural networks, we have a different types. So, and one of the interesting structure is called as feed forward networks, and in the feed forward networks it is it allows the signals to travel one way only from input to output, and there is no feedbacks, that feedback mechanism through which the output of a particular any layer does not affect the same layer. So, that means actually we have a kind of simple structure and complex structure, and this is a kind of mechanism through which the connection will be one way, but sometimes we have a multiple layers through which you can do the similar kind of forecasting. All depends upon how you have to train the particular structure structure, and then we will connect with a kind of forecasting structure through which you will do the forecasting as per the particular requirement. That means actually in the training process we have to develop the neural network structure that will be what we call as training structure, through which you can recognize a particular signal, and that signal will give you the some kind of predictions as per the future requirement. And in the feed forward networks, so the we have a kind of flexibility. We can change every time the kind of structure which is actually one of the backbone for the neural network forecastings, and that is how training stage is very important, because we have to train properly. So, we have lots of flexibility, different ways you have to train, so that this will give you a perfect path for which we can do the similar kind of forecasting. Okay, so the neural network architecture usually like this. We have actually three different structure altogether: input layers, hidden layers, and output layers. So, the interesting part of this particular neural network is the hidden layers. So, which is not actually manually visible, but what is actually visible in our structure is the input layer and the output layer. And in the input layers, so if in the process through which you can actually develop a structure, all these inputs can be linearly combined, and and then that particular combination will be help you to predict the kind of output layer. So, in this case we have actually multiple output layers, but usually we can go within a single output layers, but here we have actually a series of input layers, and these are the typical structure through which actually we will do the similar kind of forecasting. We have actually a component called as factor analysis, and neural network structure is a similar kind of factor analysis structure through which the inputs transfer into a particular factor combination, and that factor combination will help you to do the kind of output predictions. But how these inputs are connected with a particular hidden layer, that is the factor through which the output can be predicted, that is very interesting in the neural network. So, that means the hidden layer, whatever layers are there, these are all weighted combination of the input layers. So, now getting the weights to these hidden layers is a kind of interesting kind of things in the neural network structure. So, once you develop the particular structure, so by default, so the neural network forecasting will be very effective as per the particular requirement, right. So, corresponding to this particular the structure of neural network. So, let us see how we can actually process through which you can do the forecasting. So, what I have mentioned, so there are three layers: input layers, hidden layers, and output layers. So, this is the first and output, and this is the process through which you can connect these input layers, and then finally that will be connected to the output layer, which is our actually core requirement for this prediction and the kind of management requirement. The simple rule is actually how you have to actually how many hidden layers you can create, and what are the weights we have to actually assign to these inputs. So, so the training stage is that's why very important actually. So, because these weights can change as per the particular structure. So, like previous cases like moving average models, autoregressive models, we have a plenty of flexibility before you fix a particular model for the forecasting. So, neural network also having more such flexibility, because it will be continuously changing as per the particular structure you have to manually develop, and through which actually it will finally give you a perfect structure through which you can do the output forecasting. So, that is how it is a kind of challenging, and the most important challenge is how to actually develop all these hidden layer and the kind of connections that to various weights to be assigned to the inputs before you go for the kind of output predictions. And so, what is important in the neural network is the parameters. So, first is how to fix these weights, and how many hidden layers, and how many neurons, and finally, how many examples in the training set. So, that means what I have mentioned earlier, that we have actually the entire data can be divided into two parts, something for training and something for testing, and how what should be the kind of proper combinations or breakups. So, that is very important. And again, so what is the particular weight structure and the kind of hidden layer structures and the kind of neurons. So, these are actually important challenge important challenges in the kind of neural network architecture. So, once you are familiar with all these things and the kind of changes, so then you are in a position to pick up a particular models or develop a particular model, so that the forecasting will be very effective and very efficient as per the management requirement. And so, obviously, there are standard thumb rules or general rules how you have to fix up all these things. So, once you start processing, so then automatically it is a kind of continuous structure or iterative structure through which actually every time you have to learn and develop, then finally you have to actually fix as per the particular requirement and as per the best, right. So, it is a kind of flexible structure through which every time we can change till you get the best results or the best requirement for this kind of forecastings. And the rule of thumb says that at least 5 to 10 times the number of weights of the network should be fixed during the training times, and the breakup should be what I have mentioned. Actually, you must have a kind of structure through which you have enough data through which you can do the testing, so that the prediction can be accurate as per the particular requirement. And so, in the training, so the structure which you like to develop is called as backpropagation algorithm, and it has actually forward structure and backward structure, and then you can actually connect accordingly the input layer and the hidden layer through which you can do the kind of output forecasting. So, the particular structure is like this. So, in this case you see here, so the green one, it is a kind of forward structuring, and the kind of the blue one is the kind of backward structuring. That means, it is a kind of iterative process through which actually you can continuously work and develop, that is in the training stage, before you fix a particular models or the particular structure through which you will do the best predictions as per the particular requirement. So, against this same actually the indicators, error indicators we like to use every times, that is actually mean square errors, and then you have to see that or declare that the model is the best fit for the requirement. So, accordingly, so the kind of structure is to how to proceed actually and how to develop the particular requirement, that is very interesting in the neural network structure. And in fact, in the learning stage or training stage, so we usually follow two different kind of structure. One is called as a supervised learning and unsupervised learning. So, that means actually like what I have mentioned, like factor analysis, we have a exploratory factor analysis and confirmatory factor analysis. Here also similar kind of structure called as supervised learning and unsupervised learning. But in the supervised learning, so we have to give a proper kind of commands and structure through which you have to develop the particular linkage, the kind of layers through which you will do the output forecasting. But in the kind of unsupervised learning, it is not actually the kind of structure like supervised, where no proper guidance is required. So, it depends exclusively self actualization process through which you actually to develop a particular structure through which that is in the kind of training stage to get the particular models through which you can do the kind of forecasting. So, so it depends upon particular structure through which whether you go for supervised or unsupervised, but ultimately we need actually a particular structure or base structure through which you will do the kind of forecasting. The usual structure of neural network is like this, you see here, and what I have mentioned. So, we have actually input combinations, and these are all layers, hidden layers, and that is actually kind of you can have a more number of layers like this, and all inputs are connected with a particular layer with different weights, and the assign of a weight or change of weights for a particular layer is very interesting. So, how these inputs are combined with layers, hidden layers, and that too many layers, and these layers finally will be connected with the output kind of so it's a kind of weighted kind of linear combination of all these inputs to develop some factors or layers through which you can actually predict the output. This is actually very simple structure through which you can do the kind of prediction. Means similar like what I mentioned kind of factor analysis through which you will do the kind of forecasting. So, the challenge is actually the weights and the number of layers which you have developed for the at the particular training stage. So, accordingly the particular structure will be like this, and because it gives with respect to a single layers, and that is how the inputs connected with a particular weight structure, and these weights can be changed when we will change the particular setups, and the final look will be like this. So, this is the kind of complete neural network structure where we have actually plenty of inputs and different layers. So, we develop one particular structure, but it can have a multi layers and through which output can be connected. So, this is what the actually challenging part, and these are all connected with different weights altogether. Okay. So, once you develop the layers and the kind of weights, and that will give you the kind of output layer through which you will do the kind of forecasting. So, initial inputs, then the kind of hidden layers we have to create for the output forecasting. So, that is the most important challenge or most important task in the artificial neural network model, and the weight adjustment and the kind of number of layers for the output is actually very important, particularly at the training kind of situations. Once it will be trained properly and fix the particular structure, then the prediction will be very perfect. Otherwise, it will be will be kind of complicated structure, or they may be not good for the kind of best prediction or best requirement. It is a similar kind of time series model, but the thing is we just the challenge part is just to fix how what is the kind of weight structure, what is the kind of linear combination, or what is the kind of hidden layers through which you will do the kind of forecastings. So, likewise we can actually proceed for this particular structure. This is another visualization process through which because here the structure is actually starts with input layers, and these are all actually various hidden layers and connected with a simple structure, and then finally output will be connected. It is as usual actually structure of neural network through which you will do the output forecastings, and that means it is typically the game between input to output and how these inputs are connected through the particular structure to predict the business output. Accordingly, so what I will do, I will give you some of the issues here, various issues through which what I have already mentioned. So, the algorithm, we usually follow the backpropagation algorithm, that multi-layer feed forward and supervised learning through which actually to develop the models, or the kind of structure through which you will do the forecasting. Every time we have to check the error, and the model final model will be based on the kind of minimum of all these error indicators, root mean square error or mean square errors. And the particular structure of neural network, actually it is followed by a function called as sigmoid functions, and the mathematics behind this particular structure is like this, and these are all various mathematics through which you can, means whatever we have actually architecture here, it is not actually just casually developed, but it is mechanism, mathematical mechanism through which it is connected. And like every models we have a kind of functional form. So, in the neural networks the typical functional form is actually sigmoid, and that is what actually the kind of sigmoid function is all about, and this is through which the weights and the kind of structure developed through which you can do the output forecasting. And with this actually I what I can do, these are all corresponding mathematics behind this neural network model, and accordingly we can proceed, and these are the various neural networks applications: signal processing, image processing, and nonlinear modeling, time series structures, and the application wise. So, we can have actually couple of areas through which you can apply these particular models, starting with operation environment or finance environment, marketing environment, supply chain environment, medical environment. So, it is a very interesting kind of technique through which you can apply but the most important requirement is you should have a series of input combination and the kind of theoretical structure or understanding through which the input and output can be connected. And the most important challenge is the kind of the weight assigned and the kind of a hidden layer kind of structure. So, a neural network will give you the particular signal through which the inputs can be connected to the particular output or the particular requirement. So, these are the various examples of neural network modeling, and we have actually plenty of case studies through which you can do the apply this particular technique and do the forecasting as per the management requirement. So, to highlight this particular problem, so I will take a particular case, and then I will discuss how this neural network actually working. So, usually so these are all first hand inputs, and scoring examples, it is with respect to average account balance and time account opening with respect to years, and then these are all non-respondents, that means two different classification altogether. So, all the respondents and non-respondents, and then finally, with the process, so we can have here two inputs and one output, that is the score, and the training set is 1000 cases and 500 randomly for the kind of response pool and 500 for non-response pool, and finally, with the help of training and the kind of structuring, the entire structure will develop a model like this. So, this is actually a interesting model which can be actually developed through these data, and that too through neural network structure. So, that means you just see here how the first hand look, and then how it actually transport to a particular setup, and that is how the neural network challenge, and that is how the neural network technique all about. So, now in order to respond more details, so what I will do, I will take a particular problem, and then I will connect with a describe how it will work in a real life scenario. So, this is actually similar kind of structure, and every times we have the actual information and the kind of predicted information, and then once the model is developed, then the developed model will give you the forecasted figures. So, we have actual information and the forecasted information, and by default you will get the error component, and that error component need to be evaluated and validated before you go for the final prediction and final forecasting. It is actually in the forecasting structure, the final structure will be always in the basis of validation, and these are all same, whether it is a simple forecasting structures or through artificial neural network, but almost all rule is the same. Before you do the prediction, we should have actually similar kind of framework through which you develop the particular process. So, let us go with a particular examples, and I will take you to this particular spreadsheet and see here. So, this is actually a kind of big problem. So, we have more number of variables, and starting with we have around couple of independent variables, and these independent variables starting from this crime to this this much, and then this is the median value, and this median value need to be actually forecasted. So, so that means this is the output variable, and that need to be forecasted. We have actually plenty of data, and that is one of the requirement, biggest requirement of the neural network. So, that means actually the entire data what I have done here. So, I have classified into two parts, and this is what actually the test for testing, and it starts with 383 data points. That means technically, so 381 data points we have actually kept for training in this problem, and that to predict this output median value, and subject to with respect to all these independent variables. So, now what will we do? So, this will be our dependent variable, and that will be connected with all these inputs. These are all inputs, and then so we develop a particular model, artificial neural network model. So, that will give you the better forecasting about this dependent variables, and then finally, once the model will be developed, and that will be connected with testing data, and this will be a same data is actually reserved for testing. So, once you will connect with all these testing data, then it will give you the model accuracy. So, that means technically, so this is the prediction of this dependent variables subject to these independent variables, and for these independent variables some data is we use that is around 80% of the data we are using for the training and to develop the particular structure, and whatever structure we develop that need to be tested, and for that we have actually kept some reserved data, and then finally, we will check whether the particular neural network is fit for this dependent variable prediction. So, what will you do? So, we can have actually n number of software through which you will do this neural network. So, R is the best software, and you can also do through MATLAB, and it is also available in SPSS. And what I am doing here, so I will solve this problem with the Excel start, and to run this neural network in Excel start. So, R package must be installed, and then accordingly, so you just go to this neural network structure. So, here if you click here, so there is a particular framework here. So, the Excel softwares. So, the neural net item is there, just you click this particular neural network framework. So, the output the particular input box will be coming like this, and then what will you do? So, we have already connected. So, the first hand requirement is the dependent variable. So, this is the dependent variable which is connected with the this particular requirement, that is the median value, and then we have actually here the independent variable. So, this is actually the dependent variable, and then it is connected with all these independent variables, and these independent variables are recognized here. And so, this is the indication about the dependent variable from median value starting with unit unit 1, and then it will continue with the 381 data points. Then independent variables starting with A column to M column. So, that is how 1A to M 381. Then what will you go for check the options, and here the interesting part is actually neurons per layer. So, we put actually here 5 and 3, that can be actually changed. So, you can put 4 3, then obviously you can get the particular result, and threshold value we put actually 0.01, and maximum step of this you have to repetitions you put 1, and what we have done here actually. So, once you fix the neurons, then the particular functions you have to indicate, and finally, you go to the output, and these are the output requirement you can as per your requirement, but we need actually residuals, that is through which you have to check the particular structure, and after knowing all these things. So, you just put to OK. So, then continue, and by default. So, the particular structure will be yes. So, this is what the particular output, and then So, the output structure will be coming like this, and this is what the neural network output, and this is what the error component, and these are the following steps which you have actually have in this particular process. So, now the entire output will be developed like this. So, these are all observations, and this is what the median value actual, and this is what the predicted, and finally, the median value and the predicted value will get the residuals. So, this is what actually the kind of requirement, and this is what the residuals output, and this is what actually we have done in the kind of time series forecasting. So, the actual observations and the kind of this is the actual observation and the predicted observation, and then finally, the residuals. So, that means the particular model which you have actually observed through the neural network, and then the actual observation of the dependent variable and the predicted observation of this dependent variables will give you the residuals. Then finally, so this is actually available for all the data points, and whatever we have actually kept it for training and the kind of testing. Then finally, all these data points we have actually figured. So, that means technically we have a 603 observations, and through which these are all actually error component, these are all predicted figures, and these are all actual figures. Then the residuals will be looking like this, and this is game between the actual structures and the kind of predicted structure, and through which actually you do the kind of predictions. And so, the it is a more elaborative way the residuals are plotting here, and that means it gives you kind of standard structure. So, that means as usual actually when we have a kind of predicted structure with respect to the actual. So, some of the error point will be above and some of the error point will be below. So, this figure by default is actually giving the kind of signal about this, you see here. So, these are all actually above to this particular predicted line, and this is what the kind of below the kind of predicted line. So, that means the particular structure, neural network structure for this prediction is very kind of effective, and let us see how is the kind of network structure through which actually we have developed these models. If you go down, then you can get to know the kind of structure. See here, and this is what actually prediction for a new data set, because the actual structure in this kind of prediction is we have a historical data, that to the kind of actual informations, and what we have done actually on the basis of actual information, we keep 80% of data for developing the model and for training the kind of a neural network structure, and then remaining points we have kept for testing, and once it is final the models, then we extend this particular for future requirement. So, this is what the future requirement, and this is beyond the particular data points. So, it will be start with up to 603, that is the actual data availability, and now it will be the predicted figures will be forecasted accordingly. So, for next requirement as per the particular requirement. So, it will be giving you the kind of forecasted output. So, you see here the software has given the particular neural network architecture, and this is what actually the input combination. So, we have already taken actually number of inputs, and these are all inputs which you have connected. Of course, we have actually given the kind of structure about the training and testing. So, that is the part of the game of the neural network, but ultimately the entire model depends upon the architecture of inputs and the kind of hidden structure, and through which the output will be predicted. So, what I have already mentioned, this is similar kind of factor analysis framework through which you start with input combinations, then develop some kind of factors or layers through which these layers can be interconnected, and then finally allowed to the kind of output to be actually predicted, right. So, this is actually this is how the interesting part of this neural network architecture, and the idea is actually here, see here. So, this is what the interesting part. So, this is input, and these are all actually the kind of the kind of structure, hidden structures or layers or the kind of neurons through which we connect and then finally the output. So, you see here, so these inputs are how they are connected. So, the particular input with the connected with the every layers like this. Okay. Similarly, the second input can be connected with each layers like. Okay. So, this is actually mathematically or kind of structure, it will be very interesting. So, it is very what we call as technically called as path structures. So, okay. So, we have a technique called as structural equation modeling, where we can develop the particular path, then you connect and then that will help you to predict the output variable. But the beauty of the neural network is it is actually the means the machine learning process is that it automatically just develop a kind of framework, and of course, you can change the kind of layers and the kind of weights, and through which you can do the kind of predictions. So, that means technically it is a very interesting through which you have to develop the particular structure through which output can be predicted with series of inputs. But the main structure of this forecasting is to predict the output with more number of independent variables. It is actually done through simple regression structure or simple kind of time series structure, but this is another kind of technique, predictive analytic techniques, that is the machine learning techniques through which you can do the similar kind of forecasting. But interesting thing is that means if you look into the particular problem, here the problem objective is to predict the output with respect to series of inputs. So, that means till now whatever techniques we have already discussed. So, starting with simple regression, multiple regression and so many time series techniques, and again we can discuss some other techniques, and every time the structure is like this we have to set with dependent variable with independent variable. So, dependent variable with one independent variable or dependent variable with a series of independent variable. So, these techniques are can be what we can say that we have a two different kind of clusters. One particular clusters, it is directly you can connect with the particular structure. So, independent variables to dependent variable and develop the model and then get the estimated model with the help of the data, and then you can go for the kind of prediction. But in the second structures like this particular model, neural network model, where same structure we used to follow, that to connect dependent variable with independent variable, but the connection between dependent variable and independent variables in between. So, there is a different kind of a kind of structuring and the kind of restructuring, because it is a kind of continuous process through which you can develop the particular layers, and that is how the inputs can be actually connected properly, through which the output can be processed and the predicted. It is like kind of input output analysis, the inputs connected with different departments through which that will be finally come with output, then that need to be predicted. So, that means neural network is a very interesting machine learning process through which input can be connected properly to predict the output. That is the simple kind of a message through which you can get from the neural network structure, and that too for the predictive analytic structure, and that too for the kind of business requirement and the kind of management requirement. So, obviously, so the kind of structure which you have already discussed here. So, the neural network. So, so like what I have last slides which you have already highlighted. So, this is the every times the game is to check the kind of actual structure and the kind of predicted structure, and find out the error component, and that error component need to be evaluated again by the kind of indicators like mean square error, root mean square error, and check whether the particular structure or the particular model is appropriate for the future forecasting or future requirement. So, once it is okay and the model is validate, then obviously you can go for the prediction and the kind of forecasting. So, this is how the kind of structures, and likewise we means whatever examples which you have shown. So, these are all similarity, and this is how the actually the variable description through which we have actually shown this particular examples. So, the median value of owner occupied sums, that is how the actually it is a real estate problems, and so the kind of structure is connected with more number of independent variables, and that is how the results which we have obtained, and these results, this is how the input base which we have already gone through it, and this is how the residual plotting, and that is how the difference. So, the if residual plottings are giving the kind of clue that the model is perfectly okay for the kind of this particular housing predictions. So, that is how the median value of owner occupied predictions. So, this is how the neural network useful. These are all predicted structure through which we started, and this is what we have already seen, and this is the beauty of this neural network. That means, the architect and the kind of structure itself is a kind of eye catching, and that itself is a challenging for the kind of output prediction. Otherwise, the same structure you can do in a simple regression structure or simple time series structure, but the beauty of this particular how to develop the kind of layers and the kind of number of layers, and that to how interestingly you can develop, so that the output can be predicted more efficiently, more attractive way. And in fact, it is not the kind of beauty, it is a kind of comparison. This same output and input can be tested with simple regression and through artificial neural network, and then finally through the kind of prediction indicators like mean square error, root mean square error, etc. you have to check, and then finally if the neural network results are coming as per the best, then you can finally predict the particular output with neural network only. Otherwise, you can go with simple regressions where the predicted model gives better result compared to neural networks. It is not necessarily that the problem can be solved through neural network only, but the same problem can be solved through other techniques, but now through neural network we have a more number of flexibility to check the particular structure and come out with a particular model which can give you the best predictions as per the best requirement and the kind of management decision. With this we will stop here. Thank you very much. Have a nice time.